Hey everyone, hope you had a nice weekend. Now we're going to move on to the next lesson. So first thing I'm going to do is do a little bit of a review of what we talked about last time, which was sets. Okay, so one of the things that we talked about kind of near the end, and there were some questions that kind of talked about this on the quiz, were sample space. Okay, so we're going to be talking about sample space. And we said that the sample space was a set. It was the set of all possible outcomes. So there was a question on the quiz that said, what would the sample space be of rolling a six-sided die? Well, that was all of the possible outcomes of rolling a six-sided die. So you could roll a 1, you could roll a 2, roll a 3, roll a 4, roll a 5, or roll a 6. So that was the sample space, would have been the set with 1, 2, 3, 4, 5, and 6. Alright, then we talked about the event. An event was the set of all desired outcomes. That's the way I'm going to phrase it here. So you could describe an event as pretty much anything. So going back to the example of rolling a die, you could say that an event is the outcome of rolling a 6. And then that would be the set of, if you want to roll a 6, that would be the set just containing 6. If you said you wanted to roll all even numbers, that would be the set containing all even numbers, 2, 4, and 6. Now the event, okay, the event is always, help if I spelled correctly, is always a subset of the sample space. So an event is always a subset of a sample space. So I will do a quick review of what subset is as well. But right now this is just setting up what we're going to be talking about. We're going to be using these terms a lot. So we're going to be using sample space, we're going to be using event, and I'm also going to be using subset a little bit. So if you want to take a screenshot of this, okay, I'll just go ahead and give you like prompts when to take a screenshot when I'm about to erase so you can have the notes. So take a screenshot. These three terms, well, these three ideas are going to be important. Okay, I'm going to go back and talk about what subset is just as a review, because there was that one question that very few people got about subsets, so I want to make sure I cover that again. Alright. So when we talk about a subset, I'm just going to go ahead and put an example. Okay, just going to make up an example. So here's a set. I'm just going to put some random numbers in there. Let's put -3, 15, 0, 2.4, and let's put the word cat. Okay, remember, a set can have any type of elements. All of these are elements, and it can be anything. Okay, this is just a random set. It doesn't have to have any meaning. When I'm talking about a subset is a set where all of the, let me go ahead and write this out. A subset is a set that all elements are members of the original set. Okay? A subset is a set that all the elements of the subset are also in the original set. That means I can have just one element, I could have 2 elements, I could have 3, I could have 4, or I could have all 5. So 2 subsets that will always be subsets. Okay? The set itself, okay? The set itself and the empty set are always subsets. The set itself and the empty set are always subsets of a set. So in other words, here's my original set. Now the order does not matter. I could rewrite this in a different order and it's still going to be the same set. I could write it as, let's put them in order from least to greatest. -3, 0, 2.4, 15, and then don't forget the cat. This is a subset of this set because it's the exact same set. And the set itself is always a subset. Okay. Also, the empty set, so that would just be a set with nothing in it, would look like this, there'd be no elements, is a subset of the original set. Okay, I could also write this like this. So this was the most common answer for that question that said which one is not a subset. The empty set is always a subset. So this symbol right here means empty set. Okay, so empty set is this symbol here. It also can be written as just two curly brackets with nothing inside. This is always a subset. So it's possible that an event could be the empty set. Okay, that would mean like, that would be like an event, that would be like rolling a 6-sided die and saying what is the event of rolling a 7. That would be the empty set because you can't get a 7. Okay, so that's subset. This was one of the most commonly missed questions, so I want to make sure I go back over this. Now, any other combination of these elements, -3, 0, 2.4, 15, and cat, any other combination of those elements in a set would be a subset. So I could go, let's say, I'm just going to write it off to the side here. I could just pick 0, just one element, that would be a subset because 0's in this set and 0's in this set. I could go with 2 elements. I could go 0 and cat. Right? This would be a subset, 0 and cat. Because 0 and cat's also, both of those are also in the original set. But if I did something like this, and I said, let's say 0 and 4, this is not a subset because 4 is not an element from the original set. There is no 4 as an element, so this cannot be a subset. So in the quiz, there was a question, and one of the options had an element of 6, but there was no 6 in the original set. So that would not have been a subset. Alright, so if you want to take a screenshot, this is your time to take a screenshot. Then we're going to move to the next thing. This was just a review of subset since that was the most missed question on the quiz. Okay. So before we start, this is just a reminder. The set itself and the empty set are always subsets. Okay, the next thing we're going to get into is the main topic of this unit, which is probability. Alright, probability is how likely an event is to occur. So you've probably heard the word probability before. What is the probability that something's going to happen? Well, probability is just how likely something is going to happen. So it's a number. Okay, we're going to find a numerical value. It's going to be a number. And it's going to be a number between 0 and 1. Okay, you'll never have a probability lower than 0 or a probability greater than 1. The lowest you can have is 0, the highest you can have is 1, and anything in between is possible. Okay, 0 would be impossible, means it's not going to happen. A probability of 1 would be certain to happen. It means it will happen no matter what. Okay, and then the way that we can find probability, okay, and the way that we write it is with a capital P and then a parentheses, and what goes inside the parentheses is an event. So the probability of an event to occur is equal to the event over the sample space. So we're talking about how many elements are in the set. So we have the event, which is the set of the desired outcome. Okay, so this is the desired outcome. And we have the sample space, which is all outcomes. So this is how you find the probability of an event. It's the desired outcome. What are the desired outcomes over the total outcomes? And it's a number. So how many outcomes are there over how many total there are? That's how you find the probability. Okay, so it's going to be a fraction which can be changed to a decimal, and it's going to be between 0 and 1. Alright? So let's go ahead and go into an example. If you want to take a screenshot of this. We're going to go through 3 examples of very common types of probabilities. And then we'll go from there. So take a screenshot if you haven't. Example 1 is, we're going to go through is flipping a coin. So a normal coin, like here I have a quarter, it has 2 sides, heads and tails. So when I flip this coin, I'm either going to get heads or tails. That time I got heads, and that time I got tails. So there's only 2 possible outcomes when flipping a coin. You're either going to land on heads or you're going to land on tails. So if we're talking about the sample space, I'm just going to use an S to represent the sample space. That's all the possible outcomes. So we have heads and we have tails. So here's my sample space. This is all possible outcomes, heads and tails. Now an event is a desired outcome. So we can say we want either one of 2 events, right? We can have the event, I'm going to call it A. The event A is the outcome of landing on heads. So let A be the event. Let me go ahead and write this out. Let A be the event of getting heads. Okay, so I'm calling A is the event that we get heads. So the set is all the desired outcomes, which is just heads. Okay, then I could have a second event. I'm going to call it B. Be the event of getting tails. So we have 2 events here. We have A, which is getting heads, and we have B, which is getting tails. Those are 2 events. Now, if we want to find the probability, remember, I'll write it up here. The probability of an event occurring is the event space over the sample space. So we can talk about the probability of each of these. We can say the probability of A, of getting heads, A is the event, so I put A. The probability of A is equal to, well, how many outcomes are in the event of getting heads? There's only 1 outcome, which is heads. So you put the number of outcomes on top, and on the bottom you put the total number of outcomes, which is from our sample space, heads and tails. So we have 1 possible outcome, which is heads, over 2 total possible outcomes, heads or tails. So the probability of getting heads is 1 over 2, which as a decimal is 0.5. And I'm going to go ahead and change this also to a percentage, which is 50%. Okay. You see a lot of things mostly as decimals, but also can be as percentages. These are the 2 most common ways of talking about probability. A 0.5 probability is the same as a 50% chance. So if I were to flip a coin, I have a 50% chance of getting heads. The probability of getting tails, which is event B, well, we have 1 desired outcome, which is tails, over 2 total outcomes, heads or tails, which is the same thing. 0.5, which is 50%. So we have a 50% chance of getting heads, a 50% chance of getting tails. Now we can also take this a step further and say, what is the probability of getting heads, which is event A, or getting tails, which is event B? Well, back to the last lesson, what operation went with OR? Well, we had three operations. We had intersection, we had union, and we had complement. And each of those had like a keyword that went with it. Intersection goes with and had the symbol that looked like a lowercase n, like an upside down U. We had union, which was OR, and had a U shape as the symbol. Then we had complement, which went with the word not and had an apostrophe. So in this case, A or B, or tells us we're going to be doing a union. So this symbol looks like a U, means union. So the probability of A union B, well, A union B, a union means you bring the two sets together. So A is heads and B just has tails. If we put those together, we union them, we would get the set. Okay, and I'll write it down here. A union B is the set containing heads and tails. I just combined the two sets together. So the probability, well, we have two outcomes here. So that's 2, and we have 2 total in the sample space. So 2 over 2, which is 1, which is 100%. So the probability of getting a heads or a tails is 100%. If we flip the coin, we're either going to get a heads or we're going to get a tails. There's no other, it's certain that we're going to get either heads or tails. Okay? Take a screenshot because I'm running out of space, but I'm going to finish this example in the on the next part. So I'm just going to erase this bottom part so we can talk about the next part. But go ahead and take a screenshot so you have that part. So the other thing we can do, that was the probability of getting heads or tails. What would the probability of getting heads and tails be? Well, and this keyword tells us we're going to be doing an intersection. So we're finding the probability of A intersect B, which is this upside down U shape, like this. Okay, so A intersect B, well, A intersect B is going to be, what do the two sets have in common? Well, A has just the element heads, B has just the element tails. So they have nothing in common, so we don't put anything in the set. We just get the empty set. Okay? And the empty set is defined to be a set with no elements. So when we find the probability, the number of elements in our intersection is 0, and the total possible outcomes, heads or tails, is 2. So we get a 0%. So the probability of getting heads and tails in one flip, you flip a coin, and the probability of it landing on heads and tails is 0%. It's impossible. It's impossible for the coin to land both on heads and tails at the same time. So that's a 0% probability of getting heads and tails. So you can take another screenshot so you can get this bottom part, but this is the first example of flipping a coin. So probability is the event over the sample. It's what your desired outcomes over the total outcomes. And we can still use the same things that we talked about with unions of sets and intersections of sets, and we could also use complements. Okay, I'm going to go to the next example. So example 2 is going to be rolling a 6-sided die. So die is just the singular form of dice. If you just have one, it's called a die. So here I have a 6-sided die. Okay, you can see the different outcomes. We have 1, we have 2, we have 3, 4, 5, or 6. So those are the different outcomes. So I'll draw them on here. We can roll a 1, we could roll a 2, we could roll a 3, we can roll a 4, we could roll a 5, or we could roll a 6. So the sample space are all the possible outcomes. That would be rolling a 1, a 2, a 3, a 4, a 5, or a 6. That would be our sample space. Those are all the possible outcomes of rolling a 6-sided die. Now I'm going to create 2 events. Really, an event can be anything. Okay, you could be very specific, say the event of rolling a 1, or you could be more generic, the event of rolling a number that is greater than 1, an event that is rolling an odd number, something like that. The 2 I'm going to use, I'm going to say let A be the event of rolling an even number. So what are the possible outcomes of rolling an even number? Well, in our sample space, there's only 3 even numbers. We have 2, 4, and 6. So A would be the set containing 2, 4, and 6. Those are all of the desired outcomes in our sample space. We can only roll a 2, a 4, and a 6. Those are the only even numbers that we could roll. Okay. Then I'm going to say B. I'm going to let B be the event of rolling a number greater than 3. So if we look at our sample space, which numbers are greater than 3? Well, 3 is not greater than 3. 3 is equal to 3, so we don't include 3, but we do have 4, 5, and 6. So these are our 2 events. We have A, which is rolling an even number, 2, 4, and 6. We have B, which is rolling a number greater than 3, which is 4, 5, and 6. Now, we can find the probability of each event individually. So the probability of A, well, we have 3 desired outcomes, 3 even numbers, 2, 4, and 6. And we have a total of 1, 2, 3, 4, 5, 6. We have a total of 6 possible outcomes. So we have 3 over 6, which simplifies to 1 over 2, which is 0.5 or 50%. So if I were to roll this dice, my probability of getting an even number is 50-50. I have a 50% chance of getting an even number. Let's see what I get. I got 3, okay? I had a 50% chance I got an odd number, so I did not get an even number. If I tried again, I got 3 again, okay? This time I got 4, so that time I got an even number. So I had a 50% chance, which means it's equally likely for me to get an even number or to not get an even number, to get an odd number. Okay? Same thing goes with B. We've got 3 possible outcomes that are greater than 3 out of 6 total possible rolls. So that's 1/2, which is 0.5 or 50%. So it's equally likely that I get a number greater than 3 than it is to get a number less than 3. Or 3 or less, I should say. So let's see what I get. Went off camera, but there it is. I got a 6. So I got a number bigger than 3, which is what I was looking for. It was equally likely that I would roll something greater than 3 than it would be to roll something less than 3. Let's look at the union. So that would be A or B. Or means union. So the probability of A union B would be combining the two sets together. So A union B. Now this is important. If they have elements in common, you only count them once. Okay, you only count them once. If you count them more than once, you're not getting the correct probability. Okay, so if I'm combining these two together, well, I have to include everything from both sets. So 2, it's in A, it goes into the union. 4 is in A, and 6 is in A. So I'm going to have 2, 4, and 6. Now here, 4 and 6 I've already counted, so I do not count them again. I only do it once. But I do have to include 5. So here is my union of A and B. It's 2, 4, 6, and 5. The order does not matter. If you want to write it 5 and 6, that's fine. It means the exact same thing. So the probability of rolling an even number or rolling a number greater than 3, okay, we're talking about or, the probability of doing one of these two, there's 4 numbers out of 6 total, which simplifies to 2 over 3, which is about 0.67 or 67%. So this, because it's greater than 50%, that means it's likely to occur. Okay? If it's greater than 50%, that means it is likely. Alright? So if I roll this dice, it's likely that I will get either an even number or a number greater than 3. I got 1, so even though it was likely, it doesn't mean it's going to happen. If I do it again though, I'm probably going to get some of those ones. I got 6, which is both even and greater than 3, so it matches the criteria. So it was likely to occur. Alright, I'm going to erase this part and do the intersection. So if you want to take a screenshot, go ahead. Now I'm going to do the intersection. So we're going to say the probability of getting an even number and getting a number bigger than 3. So since I'm doing and this time, I'm going to do the intersection of A and B. So A intersect B, that's what do the two sets have in common? Well here, A has the element 2, but B does not. So 2 does not go into the set. A has the element 4, and B also has the element 4, so it does go into the set. A has 6 and B has 6, so it does go into the set. B has 5, but A doesn't, so we only take 4 and 6. So the probability 4 and 6, that's 2 desired outcomes out of 6 total, simplifies to 1 over 3, which is 0.33 or 33%, which means that the probability, this is unlikely. Okay, unlikely to occur. If it's less than 50%, it is considered unlikely. So if I were to roll this dice, it's unlikely that I'll roll either a 4 or 6. Well, I got a 5. I did not get it. See how many times it takes me to get one. Got a 5 again. Got a 5 again. Got a 1. Got a 1 again. Got a 3. As you can see, I'm not getting... Well, there you go. Finally, I got a 6. So it took me more tries because it's more unlikely. But a 6 is both even and greater than 3. That's what we were looking for. Even and greater than 3. Alright. That's going to be it for this lesson. Okay, so go ahead and look at the other assignments that you have to do for today. And then tomorrow I'm going to continue with the third example, as well as a different way of looking at it, and then you'll have some more stuff for tomorrow. But for today, this is as far as we'll go. So we talked about flipping a coin is a 50-50 heads and tails. But we could also look at heads or tails, which was a certain example. Or we could look at heads and tails, which was impossible. We looked at events that are likely to occur, which means they were between 50% and 1. And we looked at events that were unlikely to occur, which were between 0 and 50%.